how we went about it, how did we do the rating, and just explain the methodology of how we allotted weightages, indicators, to understand how we arrived at the final scores. So the first thing, what we would like to stress upon is green rating project is very rigorous in the sense that we take a host of parameters, quite a lot of parameters, and we do it in a very independent manner. We are not industry association, so we do it in a very independent, unbiased manner where we come out with facts and we tell them very clearly, straightforward. We are very participatory and it's a very transparent mechanism. So once we finish this process, then we release the rating. We release each company's performance very openly. We have the assessment is based on very lot of numbers. That is quantitative assessment. So we take each of the parameters, a number of parameters of industry, and look at it from numbers and rate it according to numerical methods. We also come out with a qualitative assessment of corporate environment governance, as well as, most importantly, we look at stakeholders, that is the local community around the plants. How are they perceiving about the environmental performance of these plants? So all these put together, we do the assessment. So we collect data, initially we collect data from companies. So we make a detailed questionnaire. We ask the companies to give us this data. We also collect it from pollution control boards, from media reportage, and all other media cases. We also collect, we also visit the sites. Each company is visited by a GRP team, and we look at a host of parameters for those companies which are participating, and we try to judge how what the company claims in its questionnaire, is it really true or not? Because most often what it happens is companies give sometimes rosy numbers, so we won't like to see them in flesh. So that's why we go and visit the plant. We also interact with the local community to get a fair idea of what's happening around. We make a detailed company report. It's called the company profile. So here, every parameter, every stakeholder perception is detailed, and we send that as a feedback to the company to ask them for the comments. And the companies initially, what we have found in steel sector was really, they were taken aback initially, and then they come out with their own justification and findings, and then we move ahead. We have a technical advisory panel, that is, we want some technical inputs as well as an assurance. So we have technical advisory panel, Dr. B. Sengupta, who is former member secretary, Central Pollution Control Board, Mr. A.K. Ghosh, who is former additional director from SAIL, Dr. R.C. Gupta, former professor and head, Banaras Hindu University, Metallurgical Engineering Department, and Mr. R.P. Sharma, who is the former Chief Environment of Tata Steel, Jamshedpur.
And we'd like to really thank them, they're all for with us.
Yeah. So they have provided a wealth of experience to us youngsters, and we have been able to get a fair idea of what questions to be asked, what to be analyzed, how they have guided us in that. And they have also then, when we finally brought out the results, they have cross-checked it, questioned it, and finally we have arrived at this course. So how do we push for change? Actually, we have 5 leaf category awards. So 5 leaves represents the global best. 4 leaves is good technology. 3 leaves is something which is average. A company which is just performing average is given 3 leaves award. We have found compliance conditions is a big problem, and companies which do not comply, we give them 2 leaves award. Very poor performance in terms of non-compliance, in terms of pollution, we give them 1 leaf, and companies which regularly flout norms, they get no leaves. And also companies which do not participate, generally we get information and we rate it, but they are found to be under no award. So let's just come to this steel sector, what we did about. We actually started with, we needed a size. So we took 21 plants which had capacity more than 0.5 million tons per annum as of 2009-10. This represented 68% of India's annual capacity that year. We tried a lot to engage all of them, all 21 of them, but only 13 participated. Now, this is very interesting number, which is that only 13 of them have come forward after a lot of difficulty. 8 did not. Only 1 plant of SAIL, because SAIL is regarded as one of the largest steel producers of the country, only 1 of them came forward, that was SAIL Rourkela. Once we have selected the plants, we have to actually select our boundary, that is what area do we study. So first is, we found out steel has multiple processes. So they have blast furnace, they have sponge iron, they have so many other processes which make the same product. and this brings out complexity. So we have actually made a methodology where we take into account these different processes. Second thing we have only considered is production phase. That is, we have not gone into the mining phase because many plants do not have captive mines. And finally, we have also not included the product use and disposal. That is, when a steel is made and then sold out, where it is used and disposed, we have not included because it has wide applications and steel is generally recycled. So it has low impact on environment. So that's why we have just included only the production phase for our scope. So all production plants have been rated. Next comes, we had to decide that how do we go about it. So we had to actually assign weightages. That is, weightages in other words is nothing but how much importance do we give to certain areas when we are assessing certain things. So we had given production phase 82.5, out of which iron making had the largest share. So iron making has the most amount of environmental pollution. We have given it a large share. We also analyzed a lot of the plant level, that is parameters, that is from gate to gate or from a boundary level, that what comes in and what goes out. So we had analyzed, for example, resource use, that is water, energy, as well as overall plant level pollution. We had analyzed and we given high scores. Safety and environment, we have found safety is a major concern, and that's why we have given around 7.5, and stakeholders perception around 10. Then, as I mentioned earlier, there are multiple processes, so how do we take into account this complexity? So actually what we did was we did apple-to-apple comparison. We selected a blast furnace and we compared it with the blast furnace best practice. Similarly, for a sponge iron kiln with a sponge iron process best practice. So that is how we have arrived at, that is being technology neutral. When we are now analyzing a process, how do we look at it? So we had one way of doing it was the two areas what we are concerned with is one is technology and one is how is it performing. So performance matters most, and hence we had given compliance and efficiency performance 75%. In iron making, just to give an example how we look at it, when we look at iron making, there are, for example, in a large integrated steel plant, we have coke making and sinter or pellet, that is agglomeration. So we found coke making has huge environmental impacts because of toxic air emissions, and that's why we gave it very high weightage. And blast furnace, we have given it 12, so out of these 23. So that combines into 35. Now let's look at how we analyze certain things. Now the rigor what we did was, we analyze for each, for example, we take a coke oven and a battery, we analyze for each battery how is it performing, how is its compliance, and collected all the data and we presented it very clearly. We found that a number of batteries in India, that is coke oven batteries, were not complying with norms. Thereafter, we also looked at, for example, indicators which relate to productivity and efficiency. So we found out, for example, India's average for sinter plant productivity was 1.26 tons per hour per meter square of sinter bed, whereas the global best was 1.8. So there is a large gap which is there. Everyone says Indian plants are inefficient, but we have now actually found out the reasons where they stand and why this inefficiency is there. So we have quantified that and brought out in clear numbers. So we have brought out this plant-wise, sinter machine-wise, we have brought out these kind of numbers in the report. So once doing these kind of analysis, we have say 20-30 indicators. We come out with who is the best, who is having coke ovens, and who is having the best sinter plants. So we have come out with clear numbers process-wise, and which, for example, Vizag Steel was having the reasonably best. 39% is not a good score, but it is a reasonably okay score of this. Similarly, for sinter plants, we found number of them are non-complying, and as a result, they were 33%. So it's nothing to be proud of, but for the toppers, but still there's a long way to go. Iron process, we have 4 different iron processes: coal-based, gas-based sponge iron, blast furnace, and corex. So here again, for example, we look at design of the blast furnaces. So design matters because efficiency depends on what kind of technology has been installed in the first place. So here we found out Indian blast furnaces have very low design compared to the global best, and as a result the efficiency and productivity cannot be improved after a certain stage. For sponge iron kilns, we looked at many parameters, and one of the key parameters what we also looked at was how are they performing in terms of air emissions compliance, that is how much dust emissions their chimney release, whether it is complying with the norms or not. And we found most of them were not complying. And then again we came out with scores. Blast furnace, we had say Bhushan Power Sambalpur, because it was using dry gas cleaning, there's no water is used for the gas cleaning, so that had high marks. Ispat Industries, and that was the scoring what we got for plant wise. Similarly, in sponge iron we had Godavari, which was reasonably, it's not very good, but reasonably okay, that is 24%. Then Visa Steel and Jindal Steel and Power. So this is how the scores were arrived at plant wise after this calculations. Steel making, again we did it, how much waste gas is recovered, how much energy do we recover. Actually a lot of energy is wasted. So for example, SAIL Bokaro, if you can see, we found out they don't recover any energy of this steel making process. So it's a huge amount of energy lost. In terms of money also, it's huge amount of energy lost. And we have other plants we have compared, and also with the global best. So we have this kind of analysis. And we come out again with the scores, who's the best and worst. Then we look at the plant level indicators, as I mentioned. That is how much water is used, how much land is used, how much energy is used, and how much iron ore in flux. So this indicators, we came out with numbers. We found out how much water is used. For example, we have the SAIL plants which are using huge amount of water. Of course, it is township and others, they claim that is 22 meter cube per ton of steel. Or for example, SAIL Rourkela, SAIL Burnpur is 33, Bokaro is 22. So this is huge amount of water which is used, and there are other plants which are using less. So we have compared this, both considering township and without township. Land use efficiency. Now this is another parameter which is the first time we have included in GRP. That is how well they are able to utilize their land. So we found out large steel plants are sitting with huge tracts of land. And those again who are having poor land efficiency get a score of 0. So that is how we have come out with. This is again including township and only the production land. Then we look at overall pollution impact. That is, okay, what happens inside a plant or a process is not so much of a matter for community. So how they look at how the community is affected. So they are affected by ambient air quality. What's the water pollution which is occurring outside, solid waste and carbon emissions. So these are the areas which we have looked at. In safety, we have looked at occupational safety, which we have given high weightage. Incidentally, we found every plant had environmental departments in place. So, but what we found was safety was very poor in all plants. So safety and health measures were given high weightage in this green rating project. So we found, for example, almost, which was shocking, which was almost out of these 21 plants, we found almost 50 people die every year in these steel plants. So it's a huge amount of fatality rate, and safety is a really big concern in all these plants.